Here we're being asked to find the sine of cosine inverse of 2/3 minus tangent inverse of 1/2. Alright, this looks like a handful, right? There's a lot going on here. Okay, but the first thing we notice is we see some inverse functions here, right? And remember, an inverse function is just an angle. Right? So what do we mean by that? We mean that cosine inverse of 2/3 is equal to some angle. I'm going to call it A. Then we know that cosine of A is equal to 2/3. Okay, similarly, if the tangent inverse of 1/2 is equal to some other angle, right? I'm going to call it angle B, then we know that tangent of B is equal to 1/2. So really what this means then is we really want to find the sine of A minus B. Okay, so like I said, there's a couple layers to this problem, but first thing we notice is this is just a difference formula for sine. Okay, and A and B are given by these quantities right here. Okay, so let's take a look, right? Let's just write out the difference formula for sine, right? Sine of A minus B, okay, is equal to the sine of A times the cosine of B minus the cosine of A and the sine of B. Now, where are we going to get these values from? Where are we going to get sine of A and cosine of B and the cosine of A and sine of B? Well, remember, that's just from these guys right here. Okay, that's given from the inverse function. Okay, so we can draw these out. Okay, we know that cosine of A is equal to 2/3. So if we can draw out this right triangle, okay, and this is angle A, right? Cosine of A is 2/3, right? Cosine is adjacent over hypotenuse, or you can think of it as x over r. So we know that this side should be 2, and this side should be 3. And using the Pythagorean theorem, we can certainly get the third side here, right? This is going to be 9 minus 4, which is 5, so radical 5 for that. Similarly for B, okay, we'll just draw out that angle as well. Okay, also in quadrant 1, this is angle B. We know that the tangent of B, right, is 1/2. Right? Remember, tangent is opposite over adjacent, or y over x. So this is the y value. This is the x value. Using the Pythagorean theorem again, we should be able to get the hypotenuse in this case. Right, 4 plus 1 now is equal to 5, so we get radical 5 for the hypotenuse. Alright, so what can we tell from this? We can tell that if cosine of A is equal to 2/3, then what is the sine of A? Right, the sine of A is going to be radical 5 over 3. And similarly, tangent of B is 1/2, so that means that the cosine of B should be 2 over radical 5, and the sine of B should be 1 over radical 5. Okay? And what we can do then is we can use all of these information, okay, the sine of A, cosine of A, sine of B, cosine of B, and plug these right into the difference formula right here. Okay, so let's do that, right? What is the sine of A? The sine of A is radical 5 over 3. What is cosine of B? Well, cosine of B is 2 divided by radical 5. Notice I didn't rationalize that because I know that the radical 5 is going to cancel out a little bit later. Okay. Then we get minus the cosine of A, which is 2/3, times the sine of B, which is 1 over radical 5. So just doing a little bit of simplification here now. Okay, we get 2 radical 5 over 3 radical 5 minus 2 over 3 radical 5. And in this case, we do have the same denominator here. Okay, so we'll just write that final answer here. Okay, 2 radical 5 minus 2 on the numerator, and then 3 radical 5 on the denominator. So once again, I did not rationalize this radical 5 here or this radical 5 here. Okay, so because I knew that I was able to combine them at the end here. Okay, so this is going to be our final answer.